Bismillah ar-Rahman ar-Rahim. In this lecture, we are going to discuss the linearly dependent or linearly independence of vectors. We define the linearly independence of vectors as the linear combination of the vectors are equal to or is equal to 0 if and only if all the constants are equal to 0. We defined before as the set, we said that set of vectors u1 up to un is linearly independent if the equation C1 times U1 plus C2 U2 plus up to C sub NU equal to 0 if and only if C1 equal to C2 equal to C3 up to Cn equal to 0. If all the constants C1 up to Cn are equal to 0. In that case, if this condition is satisfied, then we call the set as linearly independent. So in this part, we are going to check or discuss the linearly dependent or linearly independent of some given vectors. How to check that one? It's going to be checked by finding the rank of the matrix formed by the given vectors. For example, determine whether the given vectors are linearly dependent or independent. Number one, given that u1 equal to the vector 1, 2, 3, u2 1, 0, 1, u3 equal to 1 minus 1 and 5. We'll create a matrix from these vectors. Let A equal to vectors u1, u2, u3, which is equal to 1, 2, and 3. This is the first vector. Second one is 1, 0, 1. Third one, 1, minus 1, and 5. Let's find the rank of A. Find the rank of the matrix A. If the rank of the matrix A equal to 3, then they are linearly independent. If it is less than 3, which is the number of the vectors, in this case, then it will be linearly dependent. Or component in here, that we have 3 vectors. This is 3 by 3 matrix, square matrix. So we have 2 ways to find or to check whether the vectors are linearly dependent or linearly independent. First one, reduce the matrix to echelon form. If we have square matrix, this is square matrix. compared to row echelon form using the row operation. For the row echelon form, we can see that the first entry in the first row is equal to 1. So we are going to move to the next one. So I need to make the second row or the second entry in the first and the first entry in the second row equal to 0. To make it equal to 0, A is given by 1, 2, 3. 1, 0, 1, 1, minus 1, and 5. Now if we subtract R1 minus R2 and put it in R2. Also, I can do at the same time R1 minus R3, put it in R3. I can do it, both of them at the same time. I will have first row be unchanged 1, 2, and 3. Now subtract the first and the second. 1 minus 1 equal to 0. 2 minus 0 is 2. 3 minus 1 equal to 2. Subtract the first row and the second one. R1 minus R2. And we get 0, 2, and 2. Now, let's do the operation R1 minus R3. R1 minus R3. 1 minus 1 will give me 0. 2 minus 1 is equal to 3. For the second one, it will be 1, 2, 3. It is minus 1, so minus 1, 1, and minus 5. Then add. The meaning of R1 minus R3. Change the sign of the third row and add. So 2 plus 1 is equal to 1. 3 minus 5 equal to minus 2. So we are done from the first column. 1, 0, 0. Now forget about the first row. Let's deal with the second and the third rows. I will divide the second row by 2. R2. This will give me 1, 2, 3. Second one will be 0, 1, 1, 0, 3, minus 2. So I got 1 there. Now let's make the number 3 equal to 0. I need to convert this to 0. Do some operation to make it equal to 0. That will be 3 R2 minus R3. And put it in R3. So 3R2 will give me 3, 0, 3, 3. Minus R3, which is 0, minus 3 plus 2. I will have 0, 0, and 5. So this is equal to 1, 2, 3, 0, 1, 1, 0, 0, and 5. Since we don't have any 0 row in the echelon form, there is no 0 row. All of them have some value. So we can say the rank of A in this case is equal to 3. It is equal to the number of the vectors given there. Since there is no 0 vector in this matrix, we'll say the vectors are linearly independent. from the beginning, this is 3 by 3. For a square matrix, n by n, if the rank of the matrix A equal to n, then this vector will be linearly independent. Second method, method number 2. This is for square matrix. Square matrix means number of rows equal to the number of columns. I have A equal to, given by 1, 2, 3, 1, 0, 1, and 1 minus 5, minus 1 and 5. For this one, if the determinant of A is not equal to 0, then the vectors are linearly independent. It means that we need to find the determinant of A. Or the determinant of the given matrix A. I have 1, 1, 1, 2, 0, minus 1, 3, 1, and 5. To find the determinant, just duplicate the first column and the second one. We duplicate the first one and second one. 1, 1, 1, 2, 0, minus 1. Now to find the determinant, moving the diagonally. This is multiply DC3 and put a plus sign there. Determinant of A equal to 1 times 0 times 5. Okay, 1 times 0 times 5. There's a plus sign, plus. Second one, 2 multiplied by 1 by another one, plus 3 times 1 times minus 1. Now go to the opposite direction. The upper diagonal, this one with this one and this one, and it is negative sign. It will be minus 1 times 0 times 3. This is the first one. Minus 1 multiplied by 1 by 1. Minus 5 multiplied by 1 by 2. So we will have 0 plus 2 minus 3 minus 0 plus 1 minus 10. That will give me, this will be minus 10. Now minus 10 is not equal to 0. Since the determinant of the given matrix is not equal to 0, so we can say the vectors are, this will give me that the vectors are linearly independent. So we have two methods. This is for the square matrix, as we mentioned that. The determinant is not equal to 0 means the vectors are linearly independent if we have square matrix. If it is not, then I have to convert the matrix A into echelon form. And we found in this example the vectors are linearly independent. Another example, number 2. Take that U1 equal to 2, 6, 3. U2 1 minus 1 and 4. U3 equal to 3 to 1. And U4 equal to 2, 5, 4. And we need to check whether these are linearly dependent or linearly independent. Let A be the matrix given by U1, U2, U3, and U4. That's equal to 2, 6, 3. U2 is 1, minus 1 and 4. U3 is 3, 2, 1. And U4 is 2, 5, and 4. Let's find the row echelon form, the equivalent matrix for this one. I need this to be equal to 1. So I'm going to swap between R1 and R2. Interchange between R1 and R2. This will give me R1 will be 1 minus 1, 4. R2 is 2, 6, and 3. R3 as it is 3, 2, 1, and R4, 2, 5, and 4. Now this one, let's make it equal to 0. So I will have 2R1 minus R2 and put it in R2. That will give me 2 minus 2 and 8 minus 2 minus 6 minus 3. 0 minus 8 and 5. This will be R2. Same thing, I'm going to make this equal to 0 also. So multiply the R1 by 3. 3R1 minus R3. I will have 3 minus 3 and 12. R3 or minus R3 is minus 3 minus 2 minus 1. 0 minus 5 and 11. This is R3. So the new matrix will be 1 minus 1, 4. R2 is given by this one, which is 0 minus 8 and 5. R3 is 0 minus 5 and 7. R4 is 2, 5, and 4. Now let's make this equal to 0. So I'm going to multiply R1 by 2 minus R4. I get 2 minus 2, 8, and minus 2 minus 5 minus 4. I'll have 0 minus 7, and 4. This is R4 now. So I will have 1 minus 1, 4, 0, minus 8, 5, 0, minus 5, 11, and we have 0, minus 7, and 4. So we are done from the first row, or first column. Though in the coming step, don't use the first row to reduce the matrix. Forget about the first row now. Since we are done from the first column, don't use R1 in the coming operations. Now to make it easier, I'm going to divide this one by minus 8. R2 divided by minus 8. Or I can add just to, because I don't want to use fractions. I can use the R or minus R2 plus R4 because I have minus 8 minus 7, that will give me 1. So I'll have 0, 8, minus 5, and 0, minus 7, and 4. This will put it in R2. I'll have 0, 1, and minus 1. 0, 1, minus 1, 0, minus 5, and 11, and 0, minus 7, and 4. And let's make this one equal to 0. So multiply the second row by 5. 5 R2 plus R3 and put it in R3. We'll have 0, 5, minus 5, and 0, minus 5, and 7. I'll have 0, 0, and 6. This is R3. Same thing. Make this minus 7 equal to 0. And let's see. Can we do it? Multiply the second row by 7. R4. And put it in R4. I will have 0, 7, minus 7, 0, minus 7, and 4. Add them together. 0, 0, and this minus 3. This will be R4. So the new matrix now will be 1, minus 1, 4, 0, 1, minus 1. Now the new R3 is 0, 0, 6, 0, 0, minus 3. So we are done from the first column, second column. Let's go for the third one. This one, can you make it equal to 0? For sure. That will be R2 or 3 plus 2R4. Will be R4. 0, 0, 6, 0, 0, minus 6. I will have 0, 0, 0. This will be the fourth row. This is equal to 1, minus 1, 4, 0, 1, minus 1, 0, 0, 6, 0, 0, 0. we can see that we have 1, 0 row and 3 non-zero rows. This will give me, or this will say that rank of A equal to 3. And since we have 1, 0 row, 1, 0 row, this means the vectors, they are linearly dependent. And the vectors are linearly dependent because we have 1, 0 vector there in the row echelon form. And the rank of this matrix, which is 3, less than the number of vectors. Because of that, we can say that the vectors are linearly dependent. So this is the idea of finding or to check whether the given vectors are linearly dependent or linearly independent. Convert the matrix to echelon form or row echelon form. If you find one of the rows became equal to 0, in that case, the vectors will be linearly dependent. If none of the vectors equal to 0, then they are linearly independent. And if your matrix is square matrix, you can take the determinant. If the determinant equal to 0, then they are linearly dependent. If it is not equal to 0, then they are linearly independent.